Welcome back, everyone. In this lecture we're going to be looking at voltage dividers and also how to measure voltages in a circuit or how to check what voltage we have at a certain point compared to another point. Now this is a new term, voltage divider. However, all the circuits we've been looking at are actually voltage dividers. So what I mean by that is if we go back to a basic 2-resistor circuit in series, this here is a series circuit. But we can also call it, also otherwise known as, a voltage divider. Now you may ask, well, how so? Or what are you talking about? Well, the answer to that question is, if you have a look, we've got the voltage applied down here. So VA, let's just pretend that that's 10 volts. We know from doing our calculations, so for example, we've got R1, we've got R2. We will then do some calculations to figure out, well, what is RT? We find out the total resistance. Once we've found out the total resistance, we get the total current. Once we know how much current is in this circuit, we can start to figure out, well, what is the voltage across R1 and what is the voltage across R2? This will get a portion of the 10, and this will get a portion of the 10. So hopefully you can see that we're dividing up the voltage amongst our components. The voltage across R1 plus the voltage across R2 will equal the power supply. So, having said that, all the circuits we've been doing, as long as they've got at least two components, have been voltage dividers. Now look at this circuit here, it's a pretty big one, but it's still just a series circuit, and it's still a voltage divider, just as I've been saying. Now we've got 6 resistors, R1 through to R6. Now hopefully you can notice they're all 1K, they're all exactly the same resistance. Now think back for a moment, in a series circuit, which is the ones that we've been doing, what do you know about the current through each component? The current is the same. The current through R6 is the same as through R5, the same as through R4, 3, 2, 1. All the same current. So therefore, if I was going to ask, okay, what is VR1 or what is VR2? Well, have a think about it. To get the voltage, we need current times resistance. So to get VR1, we're talking about, well, what is the current through R1? And what is the resistance of R1? If we then do VR2, it's, well, what's the current through R2 multiplied by the resistance of R2? If we were to put values in for these, we'd find that the current through R1 is just the same amount of current through any other resistor. In this case, it's actually 1 milliamp. What is the resistance of R1? Well, it's 1K. Now let's do VR2. What's the current through R2? Well, it's just 1 milliamp. Same as R1. What's the resistance of R2? It's 1K. So it doesn't matter which resistor we do here, the numbers we use are all the same, therefore their voltage is going to be exactly the same. So we've got 6 resistors, they're each going to have the same amount of voltage. The power supply voltage is 6 volts. How much will they each get? Well, it'll be 1 volt each. 1 volt there, and there, and there, and there, and there, and finally there. R1 plus R2, VR1 plus VR2 plus VR3 plus VR4 plus VR5 plus VR6 is going to equal 6 volts. The power supply is divided up amongst these. Now, of course, if we have different values of resistors in there, some will get more than others, but still they'll all add up to 6 volts. Now, the purpose of this particular circuit is I just want you to get used to thinking about what voltage do we have at this point compared to this point. What is the difference in potential at one place compared to another? And that's why I've labeled all these different points, A through to G. Now, I'd also like to point your attention to this guy. This is the earth, otherwise known as ground symbol. This symbol here, when you see this in schematic diagrams, and you'll see it a lot in my lectures coming up, this symbol here is a reference point, and it means 0 volts. So when you see this here, we know that that point there is sitting at 0 volts, and anything connected to it, so any wires connected there, will be sitting at 0 volts. So, you've seen me say before something like this. What is VR1? So what I'm asking for there is, what is the voltage between there and there? How many volts is dropped across VR1? Well, there's 1 volt in this case. But what if I was to say something like, what is V? Let's go, we'll start easy. We'll go, what is VF? So I'm asking for what is the voltage, and I'll bring up a red one here. What's the voltage there? But what's my reference point? I need to know what is the voltage there compared to where. Well, because I've just only given you one letter here, I'm asking for what is the voltage at that point there compared to Earth. So the voltage at VF, so the voltage at F compared to Earth, because our reference is Earth because there's no second letter over here, and this will hopefully make sense as we go through these more examples. But if you have a look, the voltage at F with respect to Earth is just the voltage of R6. So it equals VR6, which equals 1 volt. What if I asked, okay, what is VE? Well, let me just erase this one. So again, I'm only giving you one letter, E. Therefore, I want to know what is the voltage. Let me get red, because this is going to line up with our multimeter leads a little bit later. I'm asking, what is the voltage at point E in my circuit? There's no second letter, therefore I'm saying with reference to Earth. So remember, Earth is sitting at 0 volts, and E is up here. It's 2 resistors up. So let's have a think. That is 1 volt, so point F is sitting at 1 volt above Earth. But there's a second resistor, this one, which also has a volt. So it is sitting at 1 plus 1, 2 volts. So VE is the combination. In fact, I'll write this up. VE is like saying VR5 plus VR6, because there's 2 resistors between that point and ground, so it's 2 volts. Let's step it up a notch. What if I said, what is VC? So I want, let's get rid of this little thing. I want to know what is the voltage at this point here. There's no second letter, so the reference is Earth. Well, if we have a look, Earth is sitting at 0 volts. We've gone up 1, 2, 3, 4. So VC is like saying VR3 plus VR4 plus VR5 plus VR6 equals 4 volts. Okay, then hopefully you can see if we went to VB, it would now be that plus that plus that plus that plus that would now be sitting at 5 volts. But what are all these ones? I've only been giving you one letter. What if we put a second letter there? Let's just move that up. Well, I'm glad you asked. Well, I asked for you. So let's say I want, okay, what is V, C, F? So there's 2 letters there after the V. I want to know what is the voltage at C. My reference point, because I've given you a second letter, that is now my reference point, and I want the reference point to be F. So let's get rid of this guy. Let's get up a black connection, and again this will line up with our multimeter leads in a later tutorial. That's my reference point. What is F sitting at? Well, F is sitting at 1 volt, because we already worked that one out before. So F is sitting at 1 volt. What is C sitting at? Well, C is sitting at 1, 2, 3, 4 volts. So really what we're saying here is we're saying what is the voltage at C, take away the voltage at F. The voltage at C is 4 volts. Take away the voltage at F, which is 1 volt. So there's 3 volts. So if you have a look in between these two, there's 1 resistor, 2 resistors, 3. Each of them have a volt, and that's how we're getting our 3 volts. What if I was to then ask, well, what is V, F, D? What does that equal? Now this one's kind of backwards compared to all the other ones we've been doing, but I'm essentially asking, so there's my first letter, F. I want to know what is the voltage here with reference to the voltage up. What did I say? D, here. Well, let's have a look. The voltage at F is sitting at 1 volt because there's only 1 resistor between ground and there, so there's 1. What is D sitting at? Well, it's 1, 2, 3. So I'm saying the voltage at F, take away the voltage at D, equals 1 volt take away 3 volts. My answer, negative 2 volts. So F is sitting 2 volts below what D is sitting at. So this is going to come in very practical when I start to actually show you how a multimeter works. We're going to be looking at how you measure voltages and current and resistance, but this one is specifically to do with voltages. So just to kind of recap what's going on here, we can see that anytime you have at least 2 components or 2 resistors, as we've been dealing with, in series, we divide up that voltage. So whatever the power supply is, it will divide itself up amongst however many resistors are in series. For this particular circuit, just to help out with understanding, I've made all the resistors 1K. Since it's a series circuit, they will all have the same amount of current. So if they've got the same current and the same resistance, they must have the same voltage. In this case, they're all 1 volt. We have 1 volt for this guy and then 1 volt for all these other ones. So therefore, when we start to look at this particular voltage, say at point B, compared to this particular voltage, say at point F, we can start to see, well, the difference between that one there and that one there is going to be 1, 2, 3, 4. So we're starting to see, well, we've got all these components. We know how much each one gets. However, how much am I getting between certain components? And again, this will come in very handy for when we start using our multimeter, and certainly very handy when we start to add lots of other components into our circuits. For example, when we start getting into transistor circuits, this will certainly come in very handy. Okay, so there's going to be some questions on this. So if you weren't sure of anything, perhaps look at the tutorial again. Go and answer the questions, and hopefully you pass all of them. Thanks for watching again.